Hi everyone, I hope you enjoyed the conference so far. In this talk, I'm going to speak about Istio at scale. I am Denis Janot, Director of Field Engineering in EMEA at solo.io. You can find my contact details in the slide, and obviously you can also find me on Slack. My goal here is to speak about the lessons learned from the testing I did when I was trying to deploy multiple Istio clusters with a lot of pods and so on. And that means, in fact, trying to deploy many control planes, many pods, but without spending too much money, if I want to summarize that. And if I look at my goal in numbers, I wanted to achieve at least 5 Kubernetes clusters, so 5 Istio control plane, at least 1,000 pods, and spending less than $100 a day. And I had different options there. GKE clusters on one side, and I say GKE, but that could be EKS clusters or whatever. Clusters provided by a cloud provider, and kind cluster on the other way, which means like having a large VM and deploying multiple kinds clusters in this VM. Both options are valid. I would say I started with GKE cluster, but it was like more expensive, but it was still like attractive. So that was not the reason why I decided to go finally with kind clusters. It's really more complex at the beginning with kind clusters, but you get a lot of advantages like you can redeploy everything very quickly. You can try out different network topologies, like having communication between pods through gateways or directly. You can run that anywhere. So it was like providing a lot of advantages. And I ended up with being able to deploy 8 Istio control plane. So you can see here 1 Ubuntu VM, my 8 kind clusters, and Metal LB running on each of them so that I can create service type load balancers and so on. I became a little bit crazy during this testing because there were like every time I was like solving an issue, I was finding another one. And the goal of this talk is that for you, it should go like that, right? It should be very easy. You should be able to relax and just like apply what I learned, and you should be able to deploy everything quite easily. So the first issue I encountered was like these too many open files, and it was quite straightforward to find out when I was looking at the Istio logs. So I got that at the very beginning when I deployed the first 250 pods in the first cluster, because I decided to go like 8 cluster and 250 pods per cluster. So that was like what I ended up with. And I found very quickly this documentation on the kind website telling about which values to modify when you get this kind of issue. And it was okay, but I put this shy guy here just to remember that I need to tell you that don't be shy with the numbers you use here, right? It's not a production environment. It's just for test. And why I say don't be shy is because if you start to use like the numbers that, for example, I got in this documentation, then yeah, you can deploy more, but you start to have the same issue again later because you reach the limit again. So don't be shy, put like high numbers so that this issue is fixed and you can move to the next one. So next one, again, trying to deploy these 250 pods. And after like, I don't know, like you see, I was still having like 199 pending. So, I deployed only like 60 something. And it was just like all of them staying in pending state, the other ones. And I finally figured out that there was this like CPU and memory request that was set by default when you deploy Istio, and for the Istio sidecar proxy. So I changed the value from the default value of 100 milli-CPU to 10 milli-CPU, and from 128 megabyte of RAM to 32 megabyte of RAM. So just change that in the Istio sidecar injector config map. And obviously, Again, you do that, you find that, you modify this value, and then you figure out you need to restart again because the pods that you deploy don't use this right value, right? So you need to either restart the current pods and it will use the new value, but you know how it is like in Kubernetes, right? If it's very often faster to redeploy a cluster than to try to delete like dozens of pods, right? So that's again one of the benefits of using kind is that you discover an issue, you delete everything, you restart from scratch, and you try again and see if you have another one. So start again, solve this problem, but again, after less than 100 pods, I found out that I cannot deploy more. It's still in a pending state. This one is quite easy to find out as well, is that basically you just reach the maximum number of pods per node, which is like by default 110. And you see I deploy less than 100, but you already have like the system pods, like the pods for Calico, for MetaLB, and so on. So you reach this limit, you change that in the kind config. There is like a kind cluster object that you can patch, and you say here I say like 1,000 pods per cluster, but you guess what? You need to restart, right? So again, I was very happy that I can do that very quickly. So just like deleted my cluster, started a new one with the new value, and this time I was quite confident, right? I already found 3 problems, so that should be quite good now, right? But then what happened is that I started to get another issue, which is like you deploy these pods like you have like one YAML that describe all these pods, and you submit this YAML file, and it's like process the first 10 or 20 very quickly, and then it starts to slow down, and then it takes like several seconds per pod at the end, right? And it's just because etcd is slowing down. So the approach I took here was like, okay, let's just create a 1 gig TMPFS, so memory file system, and again update the configuration of the kind cluster so that it use this TMPFS to as a backend for etcd. So I fixed that, restarted again, and now when I was submitting my YAML, it was like taking, I don't know, a few seconds to process everything. So a lot better. So next step was probably one of the most difficult one to solve. I was like having this fast etcd, and I was able to deploy my first cluster with 250 pods, and then the second one with 250 pods. Then I believed, okay, that looks good, right? If I can do that now, I should be able to deploy as many clusters as I want, as soon as I still have memories available, because if it works with 1, it works with 2, it will work with 3, 5, whatever. And no, in fact, at some point, after a few clusters, I started to have really weird DNS error. Sometimes it was DNS error, sometimes it was like very strange issues that you don't really understand. And after doing some research, I found out that when you run too many containers in the same operating system, you get this issue with the ARP cache. So you have different values there where you can manage how garbage collection is performed by your operating system. And there is one that represents the number of entries that you have in the cache, the minimum number. The most important one is probably the second, which is called like GC /2, which represents the maximum of entries in this cache. And after that, it starts to remove the old ones. And then you have the R maximum. So again, I just like the first one, I think the default is 128, which is very low. Imagine it cannot even keep it in the R cache like entries for more than 100 something containers, right? So it's very, very low. It was still working for a few clusters because probably even if the ARP cache was not big enough, there was not so many new entries to manage all the time, so it was okay. But with 1,000 pods, then that doesn't scale, right? So I use these values. You can use the same ones. Again, I have not been shy here, because first time I started to do like just going to from 128 to 256, but still I was having the problem just a little bit later, but I was still having the problem. So using these commands just fix that issue. After that, what I found out is that I have like a huge machine with like several hundreds of gigabytes of RAM, but still I will not be able to deploy all my pods, because I won't have enough memory if I do the calculation, right? Because I found out that each pod was using like 100 megabytes of RAM, and I wanted to do like 8 cluster, 2050 pods, and 100 megabytes per pod means like 200 gigabytes of RAM. That was a little bit too much. I was close to have enough, but was still too much. So then here what I discovered is this, the fact that by default Istio is is configuring the different sidecar proxies so that they have visibility of all the other pods in the clusters. So that means like there was like what we call envoy clusters entries in each sidecar for all the other pods of the cluster. And the more you have entries there, the more you use memory. So if you create like a sidecar object in an Istio sidecar object, you can define which pods they can see, and this special notation that you see here, which is like dot slash star, means basically that I will only see the other pods of the same namespace by default, and it's in Istio system namespace, so that means it will apply on everything. So I went from like 100 megabyte to 70 megabyte, and that means that I needed like 60 gigabyte of RAM less, which was good enough for my testing. And what's interesting is that it was all these different things, all these different steps are just like for preparing everything, right? For deploying Istio on 8 clusters and these 250 pods. But after that, I wanted to do this testing about multi-cluster communication and so on, right? And it would have been a lot worse, because the way you do multi-cluster communication is that you need to, first of all, have a discovery in place so that one cluster knows about the pods of the other clusters. So that means that each envoy sidecar would have had the visibility of 2000 pods, right? So in terms of memory, it would have been like a nightmare, and I would have need like a terabyte of RAM. I don't know, like it would have been crazy. So it was good to find this issue here and not after, because I would not have been able to scale anyway. So at the end, everything went well, but it took like 2 hours and a half to deploy everything. And again, after that, I wanted to do a lot of testing on multi-cluster communication. And if every time I want to reset my environment because I find out that I made a mistake, or I don't know, like I want to try something different, if every time I need to wait for 2 hours and a half, it's a lot of time, right? So I said, okay, let's take a bigger machine with more memory, and having like a huge TMPFS just for the storage or the backend storage for my containers. I created like a 200 gigabyte TMPFS. In fact, at the end, I don't use much. I will show you that in the environment. But using that was really nice, because I was able to go from 2 hours and a half to 45 minutes. Exactly what I wanted. And the second really positive side effect of that is that now, because everything is in memory, I reboot my machine, I start from scratch. I don't need to have this very long, if you do a kind delete cluster and you use normal storage, it will take forever, because it has to go through the directory where all these containers have been stored, and it takes a lot of time to delete all these entries. So with memory, you don't care, you reboot, it's gone, and you start from scratch again. So this is the achievement at the end, like 8 clusters, 2,000 pods, and 45 minutes. I didn't calculate the budget, but the you can do the math. It's like $3 an hour. The VM I use, it's a huge one, but still only $3 an hour. So it's less than $100 per day. And even if you want like a preemptible version, that would be less than $1. So it can be very, very cheap, and you can do very nice scale testing with it. So the next step was like, now I want like to have this multi-cluster communication, right? And the way it works with the multi-primary design in Istio is that you enable something that's called Endpoint Discovery Service. And the way it works is that each Istio, you need to create on each Istio control plane one secret corresponding to the kube API server of all the other clusters. So that one control plane will then go and reach all the kube API server of the other clusters to be able to discover the workloads. And the second control plane does the same, and the third does the same, and it's only time 4. In my case, it's time 8. In real world scenarios we have with some of our customers, it can be 50, 100. So imagine, like, it's not really nice in terms of the way it will scale, but also it has like other issues. Like if I cannot reach, if one of my API server here becomes unavailable, and one Istio control plane restart, it cannot start. You have to go and delete the secret before it can start. You have like also security concern, right? If one of these cluster is compromised, you have a secret for all the other ones. So now you can really delete everything if you want. You can delete all the pods of all the clusters and create a big mess. So with Gloo Mesh, which is our management plane for managing multiple Istio control planes, we have like a very nice design where, first of all, it's just one component, so the Gloo Mesh control plane or management plane that will be responsible for discovering everything and making the other clusters aware of what it has discovered. But the other thing that we have implemented recently, which is very nice, is that we now have like an agent that runs on each cluster. And this is the responsibility of this local agent to watch the local API server and to pass the information to Gloo Mesh using a gRPC channel. So Gloo Mesh gets all the info about all these discovered workloads, and then Gloo Mesh can use the same gRPC channel to tell the different agents what it has discovered and how to apply all the policies and so on. So it's a lot more scalable and also a lot more secure, right? Because there is no exchange of the secret of the API servers and so on. So you can do much more with Gloo Mesh. Obviously, it's not only about discovery, and I will speak about, I will kind of do a demo where I will show you this environment that I built, but I will also, in this demo, do a focus on the global failover routing, which is really an amazing feature. I could spend like an hour or 2 hours or more just to go through all the nice capability of Gloo Mesh, but I think you'll get like a good first view of what it can do. So let's go for the live demo. So I have here my environment, which is the VM I spoke before, and I have Gloo Mesh running, and you see I have my 8 clusters. I have my more than 2,000 pods deployed. So everything I described before, and I will go through a lot more details quickly. But before, let me just show you that on the CLI. So I have like different contexts. I have one for like the management cluster, because I spoke about the fact that I have like at the end 8 clusters, but in fact I have 9. So I have one for the management for like Gloo Mesh, and the 8 others where I have Istio. I could have the management on one of these 8 clusters, but it's kind of a best practice to have a dedicated one. And what you can see here that I have like just Gloo Mesh running. I don't have Istio at all. I have different components like the dashboard that you have just seen, the enterprise networking that really takes care of gathering all this information from the agents, creating snapshots based on everything that has been discovered, plus all the policies that have been created by end users, create a snapshot, give the snapshot back to the agent so that they can be applied. We have an airbag webhook, which is also very nice. I won't have time to go through the details here, but it can help you to define who can do what, like who can create what kind of policy on which cluster, on which namespace, which kind of capability, like traffic shifts, like retries, or all these different things. So that's kind of my management cluster. Now I have like cluster 1 to cluster 8, where you can see that I have like 10 namespaces, and in each namespace I have like, if I do go to the first one here, on each namespace I have like 25 pods. So 10 times 25 is 250 pods, right? So that's what I have here. I also have like in the default namespace, you can see that I have like something called like a VD, like I call it like for virtual destination. This is small UI that we will use to show this, to demonstrate this global failover. Okay, so the other thing I want to show you is if I go to cluster 1 and I look at the nodes. So you can see here that on cluster 1, my nodes is in the region US1 and zone US West 1. So at least that's what I simulate, right? And if I go to cluster 2, it's US West for same region, but a different zone. And then on number 3, it's a different regions and another zone. And I have like that, like 4 regions, 2 zones per regions. That's what I simulate here, right? And as I was saying before, the idea is that here I have like this 172.18.2.1 is the ingress of the ingress gateway of cluster 1. So if I do a get of this app, it will basically send a request to this URL, and you see this URL is the first pod of the first namespace, right? And this application, what it does, it returns information about the pod, like the name of the pod, but also return information about the region and the zone, right? So this one says, okay, I am running in West 1, right, zone. If I go to this here, which is like another ingress gateway, this is the ingress gateway of the last cluster, so cluster 8. And if I do the same, you see here that it replies with Asia 2, right, because this is where it's currently running. So the idea would be to see how we can use Gloo Mesh now, so that if this service becomes unavailable on the first cluster, I want it to go directly to the next available zone. And if the next available zone is not available, I want to go to the next region, right? So as I've shown you here, currently it just goes local, right? On this region and this one as well. One thing I didn't mention, which is very nice with Gloo Mesh as well, is that we kind of consolidate all the metrics. So what I did is that I use it to consolidate all the metrics. So all the sidecar proxies, they send their metrics to the local agent, and the local agent pass these metrics to the Gloo Mesh management plane. And on cluster 1, I deployed Kiali, and I point Kiali, instead of pointing Kiali to a Prometheus locally that will scrap the local metrics, I pointed it to a Prometheus locally that scrap the metrics from Gloo Mesh directly. And you see here, I see communication in the last 10 minutes that happened between ingress gateway of cluster 1 going to echo env1, and ingress gateway of cluster 8 going to the echo env1 here. So exactly what we've just demonstrated, right? And now to have this high availability that I discussed about, what we need is like a few things, right? So the first one is if we look at our Gloo Mesh UI, we see like we have a virtual mesh and we have like our 8 clusters. We see all the pods discovered, and we see some virtual destination and policies. So we need these two components to have this high availability of the services. So the first one, we will take a look at that first. It's what we call the virtual destination. So what we did is that we just say we will create a new host name that will be called echo env1 dot echo env service one, something like that. Let me take a look here, and we will see it. But basically, we'll just go there. You see, we have like we have made the 250 pods or the 250 services highly available. So everything is will be automatically, doing this failover between regions and zones and so on, right? So the way it works, as I said, it creates like a host name like that, and we have like backing services, right? So we say this host name, which correspond to the first service of the first namespace, is backed by 8 services because I have this service running on my 8 clusters, right? So the way I could use it is that I could just use this host name now instead of the host name I have used here, and I would have this high availability. But what we can do as well, and this is what we do in this demo, which is even more powerful, is that we created some policies so that what these policies are doing is that we say when the request is sent for the local echo env1 or echo env service 1 on the echo env1 namespace, when a request is sent locally, basically I want it to go to my virtual destination. So that now it's transparent. So that means that when I send a request here to the local service, it's basically behind the scene, highly available service. So to try it out, it's quite easy. We will fail the service here on the first cluster, and we'll see that it will automatically go to the next one, right? So let me do that here. So I'm going to. So what I do, I just replace the container used, the image used for this service because it's a very minimal one, and I use a new one, and I just like do a sleep 20 hours so that it cannot reply anymore, and it's kind of considered as a failing service by Envoy. And here, if I just go here, it will take like probably like 30 seconds to start and to terminate the other one. So you see here, it's pending the new one. So I still have the old one running, and I still need just to wait like 30 seconds or something like that. And what I'm going to do in the meantime is that I'm going to go to my UI, the service corresponding to my UI. So it's in cluster 1, and I would do like exec it exec on whatever, yeah. And here I want to do like a curl localhost 15,000 slash cluster. So these are the clusters that these are like the envoy clusters, right? So these are all the entries that it knows, right? So it knows about the local services that are in the same namespace because this is the way I configured my sidecar object. But it also knows about these global services, right? So here I can see I have like a global service, and the one I want is the one that's called 1, right? So if I just do dot global, so I made a mistake somewhere here. So this one. Oh, yeah, I don't say more. Obviously, it will not do much. So I didn't set it up. So if I do that, here I see all the entries that correspond to my 8 services, right? It has been automatically replaced by that, right? And what's interesting is that if I look at my zone, for example, I can see that I have like each one in a different zone, right? Because they are each on different clusters. And I could even see something else interesting, which is like based on the zone and the region, what Istio has done is that it has set what we call a priority. And you see here, so US West 1 is cluster 1, right? So the priority for this entry is 0. So I want to send all the requests locally first, right? And US West 2 is same region but a different zone. So it's priority 1. If I cannot go there, I prefer to go there. And then all the other ones are in different regions and they have priority 2, right? So that's basically why we will see that it will go to the next zone and then the next region. So if I go back, oops, sorry, that's not what I wanted to do. If I go back to my cluster here, I see I have like, oh, not on the right cluster, so it will not be very helpful. Yeah. So again, if I try to look at my pods here, I see it has been replaced now. And if I go to my UI and I try to access it, you see now it goes automatically on the next zone, right? Because the local one is not available anymore. And I can do the same here and just try to now make the second one failing as well. That's what I'm doing just now here. Now it's still there because, as you have seen before, it takes some time before it's replaced by the new one. So we have to wait like for a second. But what we can do as well, we can go on Kiali, and you see here it has discovered automatically that now it sends a request from one cluster to another, right? So that's what's very nice with this global metrics we have gathered from everywhere is that we know where the requests are going and so on, right? So one example is like to use Kiali, but you can also just have access to all the metrics by yourself. We are also going to add some nice graphs based on these metrics in our UI in the near future, right? Another thing I want to show you while we wait for this failing to happen here is that we have also, I spoke about the metric that we consolidate, but we also consolidate all the access logs. And here, it's not about like consolidating all the access logs because it could be a lot, right? It's really giving you the ability to specify what you want to gather. Like, let's say you have an issue at a point in time with an application and you want to understand what's going on, right? So what we can do for that is if you do go to Gloo Mesh, we created like an asset access log CRD to define what we wanted to gather. So here I said, let me just go. Come on. Here I said, okay, I want to gather all the access log for my workloads that have this label, so that correspond to my first application in the first namespace. And I want to get these logs from all the clusters in one place, right? So I configured that, and now I can use this endpoint, which is on my management cluster, so on Gloo Mesh, to gather these logs, right? And I can get a lot of very useful information here. You see here, for example, I got this log from the cluster 2, right? Because this is where I send my last request, right? And I can see a lot of very interesting information about, the identity of the pod. I can see information, obviously, about my request, performance information, but also like information, it was a get on this path, and this has been the response. And you see the same here on cluster 2 again, and you can continue like that. At some point, you will see on cluster 1 that we have like a response, 500 or something like that. Like you see 503 because that's where we failed ourselves, right? So now if I go back and take a look at my pods, I'm sure it's good. And now I can see that I'll be redirected now to any of the other uh, cluster, right? It doesn't matter now because obviously there is no priority, no difference between the different regions, right? And if I go back to Kelly here very quickly, you see, I see that it goes everywhere right now. You see that I got like requests going to all the different clusters. So yeah, I think that's you have a good idea now about how it works. We've just shown a few capabilities of Gloo Mesh, but I think you already can see how it can simplify your life if you have like multiple Istio clusters. So I hope you enjoyed the talk, and we have some time for Q&A now. Thank you.